Okay, question 2. Question gives us an equation. F of x equals 4 cosec x minus 4x plus 1. X is in radians. And for part A, we've got to show that as a root f of x equals 0 between x equals 1.2 and 1.3. Okay, so let's consider x equals 1.2. First thing, calculator, make sure it's set up correctly. It's in radians. Oh, that's good. I'm going to put in x equals 1.2. Okay, so x is now being defined as 1.2. I'm going to make a formula up now. So 4 over sine x, because obviously we can't put cosec x in the calculator, minus 4x plus 1. And we get x equals 1.2. That gives me f of x equals 0.492. Now we're going to look at x equals 1.3. Redefining x as 1.3. Scroll back up to the formula. That gives me minus 0.049. Okay. Sign change between x equals 1.2 and x equals 1.3. Now, a thing we do have to think about, be careful, is that fx isn't a continuous function, but from a graph of cosec x, we know any discontinuities occur at 0 and pi, so it is continuous between 1.2 and 1.3. Therefore, a root between these values. Okay, part B now. That's just asking us to show that the equation for cosec x minus 4x plus 1 equals 0 can be written in the form x equals 1 over sine x plus 1 over 4. Okay, we're working with this one then. I'll rewrite that as 4 over sine x minus 4x plus 1 equals 0. I'm going to rewrite that, looking at where we're trying to get to, as 4x equals 4 over sine x plus 1, so x equals 1 over sine x plus 1 over 4, which is where we're trying to get to. Okay, question 4c now. We're using the rewritten form we got in part B as an iterative formula to get a more accurate solution. So we're starting off here, and we've been given x0 equals 1.25, and we need to find x1, x2 and x3. and the questions want them to 4 decimal places. Right, so it's back out of the calculator. I'm going to start off defining x as 1.25, which is done there. Now I'm going to write out the iterative formula. 1 over sine x plus 1 over 4, and that gives me 1.3038 to 4 dp. Okay, I'm going to store that as x, back up, run it through again, 1.2867, again, store that, back up to the equation, run it through for one more time, 0.2917, and we can just 4 dp. Okay, part D is now considering a sign change of the original function. It's telling us that alpha is 1.291 to 3 dp. So I'm going to use upper of f 1.2914. So I need to go back to the original function. Let's put in 1.2914 and store that as x. Going back to the original function, which is probably somewhere in my calculator, but I'll rewrite it. So, oops. Sine x minus 4x plus 1. And so that equals a pretty small negative number, 4.23 times 10 to the minus 3. Okay, let's consider a lower bound. 1.2905, which will also round to 1.291. 1.2905. That's stored in the calculator. Run it back through the formula, and I'm left with 4.46 times 10 to the minus 4. Okay, that's negative, and that's positive. So within the upper and lower bounds, we have a sign change, and as we discussed earlier, the function is continuous within that range. Therefore, there must be a root at 1.291 to 3 decimal places.